Hi, grade 9 students of Batasan Hills National High School. I am Ma'am SN or Ma'am T, and today we will discuss how to solve for the empirical and molecular formulas. But before that, let us have first a recall of the definition of empirical formula. So what is an empirical formula? It is the formula of a compound expressed as the smallest possible whole number ratio of subscripts of the elements in the formula. How do we make this statement understandable? When we talk about empirical formula, take note of this. It is the simplest or the most reduced ratio of atoms in a compound. While when we talk about molecular formula, it is a formula of a compound in which the subscripts give the actual number of each element in the formula. That's why we call molecular formula as the regular formula. It deals with how many atoms of each element are in the compound. So I hope you were able to grasp the definition. As we go on with our problem solving, you will learn deeper more on the definition of these two formulas. So let's have an example problem. Let's start with calculating empirical formula. So how do we find or how do we solve for empirical formula? Let's have an example. Chemical analysis of a liquid shows that it is 60% carbon, 13.40% hydrogen, and 26.60% of oxygen by mass. Calculate the empirical formula of this substance. If you look at the problem, guys, you're given percentage composition. Previously, you were able to discuss that. So our step one is to convert it to grams. So assume that you have 100 grams sample and convert percentages to grams. So that 60% carbon is the same as 60 grams of carbon, and that 13.40% of hydrogen is the same as 13.40 grams of hydrogen, and 26.60% of oxygen is the same as 26.60% or 26.60 grams of oxygen. So what is our step number 2 or the next step? All you need to do is convert grams to moles. So if you can recall in our previous slide, we have 3 given. So let's start with 60 grams of carbon. So how do we find for the number of moles of carbon? Simply, you're given 60 grams of carbon. All you need to do is find its atomic mass using your periodic table. And carbon's atomic mass is 12 grams, obviously for every 1 mole of it. So multiplying 60 grams of carbon to 1 mole of carbon over 12 grams of carbon, the answer is 5 mole of carbon. Next is 13.40 grams of hydrogen. So the atomic mass of hydrogen is 1 gram for every 1 mole of it. The answer, once you multiply 13.40 with 1 mole over 1 gram of hydrogen, the answer is 13.40 moles of hydrogen. And then the last given is 26.60 grams of oxygen. So the atomic mass of oxygen is 16 grams for every 1 mole of it. So 26.60 grams of oxygen times 1 mole over 16 grams of oxygen, the answer is 1.66 mole of oxygen. So what is the next step? The next step, guys, is to identify which among these 3 values or 3 numbers is the smallest. So obviously, that's 1.66 moles of oxygen. This is the smallest decimal in moles. So you divide all the other decimals and itself by that number. And that is step number 3, dividing each by the smallest decimal to get the whole numbers. So divide by 1.66. So for the first one, for carbon, the answer is 3.01 mole of carbon. And then for hydrogen, the answer is 8.07 mole of hydrogen. And for oxygen, obviously, you will have 1 mole of carbon. Okay, so this is the last step. The answer is no. That is because you need to round these answers to the nearest whole number and use them as subscripts on the final empirical formula. So finalizing our answer, the empirical formula is C3H8O1 or C3H8O. So I hope you guys were able to learn from our first example. Let's move on to our next or second example. Let's have this problem. A compound consists of 72.2% of magnesium and 27.8% of nitrogen by mass. What is the empirical formula? So step one, just like the previous problem, all you need to do is convert percentage to grams. So 72.2% of magnesium will become 72.2 grams of magnesium, and that 27.8% of nitrogen will become 27.8 grams of nitrogen. Step 2. Convert grams to moles. So we have 72.2 grams of magnesium. Find the atomic mass. The atomic mass using the periodic table is 24 grams of magnesium for every 1 mole of it. So multiplying 72.2 grams of magnesium with 1 mole over 24 grams of magnesium, the answer is 3.01 mole of magnesium. And 27.8 grams of nitrogen, multiplying it with 1 mole of nitrogen divided by or over 14 grams of nitrogen, the answer is 1.99 mole of nitrogen. So same step. Find the smallest value or smallest number, that is 1.99 mole of nitrogen. Divide each by the smallest decimal to get the whole number. So let's divide the number with 1.99, or divide the answers or the number of moles with 1.99, which is the smallest value. So the answer for the number of moles of magnesium divided by 1.99 is 1.51. And obviously 1.99 divided by 1.99, the answer is 1 mole of nitrogen. Are we done with this? The answer is no. That is because still these numbers or these two values are not whole numbers. We have to get rid of 1.51. If we multiply by 1, we get the same number, of course. So let's multiply by 2 and see what happens. Remember, whatever we do to one side, we do it to the other side. So 1.51 mole of magnesium times 2, the answer is 3 moles of magnesium, and 1 mole of nitrogen multiplied by 2, the answer is 2 mole of nitrogen. So we have now our empirical formula. The answer is Mg3N2. So I hope you were able to get how to solve for the empirical formula. So let's have molecular formula. How do we solve for molecular formula, or how do we determine the molecular formula from the empirical formula? So let's have an example problem. The empirical formula of a compound is P2O5. Its experimental molar mass is 284 grams per mole. Determine the molecular formula of the compound. So our step 1 for finding the molecular formula is to find for the molar mass of the given empirical formula. And for this problem, the given empirical formula is P2O5. So how many moles of phosphorus are there in the given empirical formula? So there are 2. So multiply that with the atomic mass of phosphorus. The answer is 62. Simply multiplying 2 with 31, you will get 62 grams. While for oxygen, there are 5 moles of oxygen. Multiply it with its atomic mass, which is 16. The answer is 80. So you get the sum of these two numbers, 62 plus 80. The answer is 142 grams per mole. What are we going to do next? Next step is molar mass of the compound divided by the molar mass of the empirical formula. Or shall we call it the experimental molar mass of a compound, which is given in the problem, divided by the molar mass of the empirical formula that we computed previously. So the given experimental molar mass of the compound is 284 grams per mole. So you divide it with 142 grams per mole, which is the computed molar mass of P2O5. So the answer is 2. Okay, what's next? Step 3 is multiply the subscripts from the empirical formula by the answer you got in step 2. So the empirical formula given in the problem is P2O5, and our answer in the computation for step 2 is 2. So 2 times P2O5, the answer is P4O10. That is now the molecular formula of the compound. So I hope you guys was able to grasp how to solve for the molecular formula. So don't forget to like this video and subscribe to this YouTube channel. See you in our next discussion.